Assalamualaikum and good day everyone. We will continue this chapter 5 with the next topic where we will demonstrate to you on how to perform box checking models using R programming. Okay, so based on our last class, I hope that everyone familiar with the words of ECF and PACF. Okay, you can distinguish between the different of ECF and PACF. Okay, and based on this ACF and PACF, this is just a general rules to 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 become your model identification guide. But this is not finalized. You don't choose only one model based on this model identification. Okay, so maybe based on this model identification, you can start with an initial value and then you can propose others competing models that have different P and Q. Okay, but by reading the ACF and PACF, you can suggest okay what are the initial models that you can distinguish based on the patterns of uh, the spikes. Okay, and we also do this exercise where you construct the ACF and PACF plot based on this table. Okay, so as you can see here, the value of ACF and PACF not exceeding plus minus 1. Okay, so because it's some sort of explaining the relationship of the lags and the and the different lags. Okay, and uh, in this particular example, I also show you on how to calculate the confidence band. So this is actually 95% confident band because we use 1.96 here plus minus over square root of t, where the t is the observation, how many observation that you have in your data. Okay, and when you draw the ACF and PACF, make sure that you have this kind of spike. You can draw it in a single line or you can draw like bar, okay, like a bar here, and identify which of this spike is beyond the confident band. Okay, so anything that beyond confident band, we say that it is a significant spike. Okay, and you can based on these rules model identification guide, you can actually suggest the initial value. Okay, the initial value for P and Q as your first models, and then we can tune the models by suggest suggesting any others competing models. Okay, maybe you can based on this suggesting an as example ARMA 1 and 1. So you can also take a look at what if we models ARMA 2 1 towards our data, or ARMA 1 2 towards our data. Okay, so based on these particular models, you check the value of the information criterion such as AIC and BIC, and you take a look which models that give you the smallest one. So the smallest AIC or BIC will be can be your best models to do forecasting based on box ranking method if you compare with these three models that I mentioned before that you select. Okay, but ARMA 1 and 1 is only the initial models. Okay, we we commonly suggest another alternative, even though that this particular ACF and PACF is very clear cut the order of P and Q. Okay, sometimes the spice cannot explain the true characteristic of the data because this ACF and PACF if is only the sample ACF and sample PACF. Okay, right. This is examples, and what we want to show to you today is this particular stages where we do model identification toward this particular data set. Okay, so based on this instruction, we will use the SMP 500E mini features EF equals to F daily adjusted close prices downloaded directly from Yahoo Finance via the Quant Mode package. Okay, so what I want you to do in your R Studio, make sure that you set up this first. Okay, you call the library Quant Mode. Okay, after that you copy these get symbols and make sure that this is properly copied, and make sure that you have this EST SMP EVA SNP in your environment. Okay, like my examples here, I have SNP, so means that I successfully call this particular data set. Okay, and then I will take a look whether I have EST SNP. Okay, EST SNP EST, okay, EST, okay, this one, right? EST SMP, it means that I already successfully read this data, and EVA underscore SNP. Okay, so this particular codes actually you can find this in my notes. Okay, from this one. Okay, you show our code here. You show our code. You copy this one, get symbols, and then you copy this one up until this one. Okay, and then you run and make sure that it is in your environment. After you confirm that, and we will start doing the exercise of using plotting the SMP features and so on until we reach the step of doing box checking models. Okay, all right, now let's take a look at our data set. Okay, so it's actually you can plot the original data. This particular original data SNP is actually being divided into two parts. Okay, the estimation parts and the evaluation part. So means that we will estimate the parameter based on the estimation part, and also we will select the model based on the data of the estimation part data. Okay, right. So what we do first, we have to take a look whether our data is stationary or not. Okay, so we have to decide whether it is a stationary data or not. So what you can do is, okay, if you want just a simple plot, you can use plot function, okay, EST underscore SNP, and then you run. Okay, when you run this particular plot, one thing that you will notice is there is trend line here. Okay, so this particular trend component have been signal that this is a non-stationary series. Okay, nevertheless, as we can see here, there is no seasonal pattern in our data, so that's why this is non-seasonal box Yankee models. Okay, alright, after you plot, you can also okay, you have to describe this particular plot. Okay, there is a upward trend, okay, based on the data and so on. Okay, and then you can also plot the ACF and PACF. Okay, based on this, we will plot the ACF for EST underscore SMP and also PACF. Okay. Okay, suppose that you want to combine these both plot. Okay, you can actually do this thing. Okay, par and fro C1 C1 2. Okay, par and fro. Okay, par and fro. This one. Okay, par and fro C1/2. So when you plot the ACF and PACF, this will be side by side plot. Okay, right. And then based on this, you can see that even at the lag 20 for this particular ACF or lag 30 for this particular plot, the ACF is slowly decaying. There is slowly decaying pattern for the ACF. So this is actually a clear sign of non-stationary. Since that this is non-stationary, we still cannot identify the order of our P and Q based on the rule of thumb at above before this, because we have to make sure the data is stationary first. Okay, and you can also test this based on ADF test. Okay, so what we do is we perform ADF test. Okay, ADF test, it means that I believe that you need another library, forecast if I'm not mistaken. Okay, EST underscore SMP. Okay, so maybe library T series. Yes. Okay. Alright. Okay, so means that ADF test is actually in T series library. So make sure that you call this library first before you performing the ADF test. Okay, so based on the ADF test, the p value is 0.2192. Okay, 2.192, and it's greater than 0.05. Since that this is greater than 0.05, we fail to reject H null. Thus the series is not stationary. Okay, so even based on plot, based on the decaying pattern of the ACF, okay, based on the ADF, we say that the SMP data is not stationary. So the thing that you need to do is actually you have to do the first order differencing. Okay, we will use diff function to do the first order differencing and investigate whether this first order differencing already turn our data to a stationary series or not. Okay, right, so you can copy this one. Okay, copy this one. Okay, and you run. You can clear your console, you run, and then you try plot the series that have been okay. Alright, oh, you have to reset this back, or else they will have this two column, one row. Okay, so I reset here, part and fro, I put it one and one again. Okay, so now they have this kind of plot, as we can see here. Even though that there is a slight outlier observation here, okay, the data now seems that they fluctuate around a fixed value, a constant value. Okay, so this is one of the identification that the data is already stationary, but we have to confirm with the ADF test and also the ACF. Okay, so when we do the ACF, okay, suppose that you want to put it like before this, okay, so you can use the ACF towards the data that have been different, and the PACF. Okay, and then you run. Okay, since that when you perform the differencing, okay, there will be an A here. So when there is an A here, you cannot perform this ACF and PACF. So what we do, we just put the I love to use this. Okay, not. So we have to omit. So NA dot omit. Okay, so the same as this one lah. Okay, so we run and we run. Okay, so this is the ACF and PACF for our data. Okay, and based on this, there is no more decaying pattern for your ACF. It seems that the data turn into a stationary process, and you can also confirm that with the ADF test. Okay, but even the ADF test also have to use this one, the NA omit one. Okay, and as we can see here, the p-value is 0.01. Since that p-value is 0.01, we reject the null hypothesis. So the difference series is now stationary. Okay, and the order of differencing is d equals to 1. Right. So when we do the differencing now, okay, before you identify the order of P and Q, okay, before you identify the P and Q, okay, now you know that this is actually ARIMA models. Okay, why ARIMA models? Because you already do the differencing, which is the first differencing, d equals to 1. But now you have to determine what are the P and what are the Q, the AR order and the MA order. Okay, so now what we can do is we can actually identify the initial value of our P and Q based on this ACF and this PACF. Okay, so for ACF, we will determine the significance spike. Okay, Q is number of of 6 spike in ACF. Okay, in ACF, whereby this is AR P is number of 6 spike. Okay, let me number of 6 spike in PACF. Right, so let's take a look on this ACF and PACF. Sorry. Okay, so this is one significant spike. Okay, so we can consider that the Q is equals to 1. Okay, so we can consider that the Q equals to 1, and for MA you have 2. Okay, 1, 2. So you can consider so for ACF you have 2 significant spikes, so you can consider that the P order is equals to 2. Okay, So here, based on our investigation, P equals to 2, Q equals to 1. Okay, so our initial model, based on this model identification, we can conclude that this the models that we can take as the initial model is ARIMA 211. Okay, 211, based on this spike. Okay, why I can read this spike as the order of P and Q, because now this particular data is already stationary after we do the first differencing. Okay, so you have to make sure that the data is stationary first, and next you identify the order of your P and Q. Okay, right. So the stage 2 is, okay, let's say that we suggested model is ARIMA 211. Okay, now we have competitive models to compare uh, that can be near to this ARIMA 211. As example here, ARIMA 110 and ARIMA 212. Okay, so how we'll do the model estimation? Okay, for this particular estimation, we will use model ARIMA. Okay, let me take a look at your notes first before I proceed. Is it they use this kind of code? Okay, wait. Okay, so oh yes, they use tables, model ARIMA, fables. Okay, so the slide use this particular package, whereby I actually have another way or more simple way compared to this one. Okay, but it's okay, I just use the what are the slides or the common notes mentioned here. Okay, so we need these two, library fable and library T symbols. Okay, so here let's do uh, some works here. Okay, you put library here. Okay, library fable, library es decimal. Okay, right. Oh, extra B. Okay, all right, now let's take a look at this one. Okay, we will turn this particular example okay. Let's follow the examples. Okay, and then you run, this should be okay. So depending on the ARIMA order, Okay, you just adjust this number. Okay, so they will be your first model, the second model, the third models. Okay, and for every models here we will get the report. Okay, means that what are the estimation based on these particular models. Okay, right, so let's do this one. Okay, and then you just run. Okay, and then okay, you call the first model first. Okay, the report. Okay, and then you proceed with others models. Okay, and then you run. Okay, so okay, based on this, we will take a look at what are the lowest AIC and BIC. Okay, so let's take a look at the first AIC here. Okay, so the lowest one should be the Arima 212. Okay, and we confirm it with BIC. Okay, so BIC, this is quite high compared to others, compared to this Arima 110. So we have another one to check. Okay, which is AICC. Okay, so AICC stated that this Arima 212 is the lowest one. So means AICC say that this model is the lowest one, whereby BIC is Arima 110. Okay, so because there are two criterion that flag this as the best model, so we will use Arima 212 for our model. We can say that Arima 212 is the one lah. Okay, alright. Alright. Okay, the model with the lowest AIC BIC is selected as the best models. So that's why we say that Arima 212 is the best, since that this is the lowest one, this is the lowest and lowest. Okay, and we have to validate the models. Okay. Since that we already choose our Arima 212, we have to validate. So how do we validate our models? Okay, so we can take a look based on the Leung-Bok statistic, based on Leung-Bok test. Okay, this is example for 211. Okay, but it's actually um, based on the AIC comparison. The model that we should tested is Arima 212. Okay, we just adjust the code. Okay, right, so here I will take a look at 212 instead of 211. Okay, because we decide that 212 is the best models. Okay, so what I will do is I get the residual first. Okay, okay, I copy this one. Okay, I copy this one, but the thing that I will adjust is this is 212 and residuals is 212. Okay, and then this is also 212. Okay, okay, right, so based on this, okay, based on this, the p value is 0.1017. Okay, the p-value is 0.107. So we still can use this particular uh, particular conclusion. Since that p-value is greater than 0.05, we fail to reject the null hypothesis. So we conclude the residuals are white noise. Okay, if your residual are white noise, this is one of the identification that your model is well specified. It means that we can use the ARIMA 212 as your model to forecast. Okay, so this is the residual ACF and VACF, and after that, okay, we can actually do the forecasting, okay, based on these models. Okay, how do we do the forecasting? Okay, how do we do the forecasting? Okay, okay, so uh, the first thing first is you have to forecast this, you have to use the entire data, okay, not SMP EST. Okay, from this we use EST underscore SNP is to estimate the models, to reach the best models. What are the specification? Okay, so we reach that this actually M212. So what you can do is okay, the first step is this is the recalling the all the data set, and then you perform the data to full data set. Okay, this is I adjust because based on my evaluation it should be 212. Okay, okay, so right, and then this is the forecast. You only have to adjust the models. Okay, full forecast 212 times step forecast. Okay, so when you specify the horizon h equals to 10, so this is uh, the the 10 step forecast, right? And this is the confident band, the color one here. Okay, 80%, 95%. Okay, so you can actually uh, you can actually uh, put it as 90, 95, or any suitable confident band value. Okay, and then you just run. Okay, before that, to make sure that this particular plot is successfully run, okay, so you have to make sure that uh, the needs components of this particular plot is being called. Okay, the first is you have to call the library ggplot2. Okay, library ggplot2, and also this theme. Okay, this theme that I've been prepare for you in this one. Okay, the custom ggplot theme. So means that you need ggplot2 and also the theme ts if you want to follow a z plot. Okay, so when you call this particular library, then you run, and then you run, and you will get this particular plot. Okay, the full plot with the forecasting plot. Alright. Okay, so this is the step that I want you to follow, and make sure that you save your code. Suppose that you have any problem regarding the codes later, we can discuss during our class. Alright, and I will explain in details about the step again to make sure that everyone understand how you can reach this identification step. Okay, alright, so I think that's all for today. Thank you for listening. Bye.